Our next FRQ type is graphical analysis, and this comes up on most AP exams, but it's always in a slightly different way, so it's not as nice as like linear motion and rate in, rate out, which always looks very, very similar. But graphical analysis, again, how can you tell if it's a graphical analysis? There's a graph in the problem. Maybe it's not always a graph, maybe they give you a function and you need to graph it, but chances are if you see a graph at the top, 9 times out of 10, it's a graphical analysis question. So one thing that's important, if they're giving you the graph, whether it's of the original function or the derivative, make sure you remember the connections between the derivatives, increasing, decreasing, and concavity. So if the derivative is positive, your original function's increasing. If your derivative is negative, your original function's decreasing. If your second derivative is positive, your concave up. Second derivative is all about concavity. Also remember, derivative is the slope of the tangent line, so they might give you this function which has a bunch of lines on it, and you have to do something with the derivative. Remember, the derivative is going to be the slope of those lines. They might also ask you to find an integral of the derivative. I remember if you do the fundamental theorem of calculus, you take the antiderivative and then plug in the bounds. So you might just be able to use the graph to figure that out quickly. All right, so here's our 2022 question. That was a graphical analysis question. All right, so we have this function, it's a semicircle and then 2 line segments. All right, this is the graph of f prime. Oops. So make sure you're, again, just careful with reading the graphs and things. All right, right here, we're f prime. So we want to find f of 0 and f of 5. So how do we go backwards from my graph of f prime to f of 0? That's when I use my accumulation to change formula. So if we look at the solutions, accumulation to change formula is your starting value I know, and they told me right here, they told me the starting value f of 4 is 3. So I take my starting value and I go from the starting value to my ending value. If I do all this, and this is just stuff you can figure out using the graph, you can figure out f of 0. Same thing, we want to end at 5, do the same thing. So this is area of either region, you get 1.4. All right, so that's kind of this part. And actually finding each answer is worth 1 point each. So this one, pretty much need to get it exactly right to get the 3 points. But you can see if you're trying to go from the derivative to the original function, you have to use this accumulation of change formula. So you can see, I think this is our 3rd type of FRQ we've gone over. All 3 examples we've done have used this accumulation of change formula at some point. So it's one of the most important things you can know for the FRQ part of the test. All right, but B, find the x-coordinates of all points of inflection. All right, so this one, just sentences. To find a point of inflection is when your original function is concave up and switches concave up to concave down. It's also when your derivative goes from increasing to decreasing. So if I go back to my question, when does my derivative go from increasing to decreasing? Here and here. So 2 and 6 are the answers, and you can see that's pretty much what the whole thing is. All right, say it's 2 and 6, because that's when your f prime changes from decreasing to increasing, or vice versa. And it's the derivative changes from increasing to decreasing. All right, part C. All right, we have this new function. On what intervals is g decreasing? Well, if something's decreasing, we need to consider its derivative. So you get 1 point for knowing to do its derivative, which is pretty simple. And then figuring out when this derivative, if it's decreasing, it means the derivative is negative. So we need to figure out when this derivative would be negative. Well, f of x minus 1 is the same as if we just shift this whole graph up, so it's there. And when's it negative? Everywhere but, or from 0 to 5. Right, so you see that gets you 0 to 5, gets you the other point. All right, but the first point, pretty simple to get. You have to do increasing or decreasing. You have to find the derivative of this function. You get a point for that. In part D, all right, for the function that was defined in the previous part, find the absolute minimum. So absolute minimum means we're doing the candidates test, which means I need to find the critical point. So you see, you get a point just for knowing you have to find the critical points when the derivative is 0. You can find those values here. Then answer with justification. You do the candidates test like that. And they do it in kind of a slick way, but I wouldn't expect you to figure out the slick way on the test. Just do the tried and true method doing the candidates test. All right, so graphical analysis is a big thing in the AP curriculum and all that, so you can kind of guarantee there's going to be some type of free response about graphical analysis, knowing how concavity, increasing and decreasing are all connected. Most of the time, again, you have to be careful with things like this, that they're giving you the derivative function. So they're asking you like, what is f of 0? If you put 0 and 1, all right, you're thinking of this as the original function f, but a lot of times they give you the derivative graph because it takes a lot more thinking on your part to answer questions about the original and that type of thing.